Refining in Aqua Regia is a simple and easy procedure, but like anything new, it can be a little intimidating, especially since you are working with gold. Don't worry. Even if you screw up massively, the only way to lose your gold is to literally throw it away. Just take your time, follow the instructions, and you'll do fine. And if you have any questions, just contact tech support. They will be happy to help you. And, unlike me, they are actual, real people. The Aqua Regia refining process is quite simple. There are 4 basic steps. Dissolve your metal in an Aqua Regia solution. Remove any undissolved solids from the solution. Convert the dissolved gold into particles by adding a selective chemical, leaving all the other metals dissolved. Recover the gold particles from the solution. 100% recovery with 0 losses is typical. And typical purity is at least 99.95%. Well, that is the overview. Don't worry if it seems a bit overwhelming. I'll walk you through it, step by step. You'll find the process to be quite simple, straightforward and easy. And, of course, if you have any questions or concerns, tech support is there for you. Now, let's take a look at what comes with the system. Reaction chamber. Base with spot plate. Basket and filter pouch. Precipitation cap. Treated activated charcoal, non-toxic chemicals. Measuring cup. Dissolution cap. Drip wheel. Pipettes. Scrubber. Measuring spoons. Stir rod. Test solutions. Timer. The Aqua Regia process dates back over a millennia, and has traditional used nitric and hydrochloric acids, as well as toxic and corrosive precipitants. Shor R&D has developed non-toxic, effective substitutes for both nitric acid and the precipitant. These safe substitutes, MX3 and quadratic precipitant, are utilized in this system. However, should you want to use the traditional, toxic chemicals, this system will accommodate those as well. Just follow these simple video instructions, and you will safely and comfortably refine your gold to 99.95%, with no losses, even the first time you use this system. Dissolving your metal. The first step is to dissolve your metal. For this, you will need hydrochloric or muriatic acid, MX3 concentrate, measuring cup, measuring spoons, base, reaction chamber, with basket, pouch, and cap, scrubber with charcoal, and, of course, your metal. Weigh your metal. Weigh an equal weight of MX3 concentrate. Whatever weight your metal is, you will be adding an equal weight of MX3 to dissolve that metal. If you prefer, you can measure the MX3, instead of weighing it. The ratio is 2 level tablespoons of MX3 for every ounce of metal. Add the MX3. Add your metal. Hydrochloric acid, also called muriatic acid, is the final ingredient needed to dissolve your metal. You will want to add this under either very good ventilation, or out of doors. Use 15% strength hydrochloric. If your acid is about 30%, then add an equal volume of water, either tap water or distilled, to bring the strength down to 15%. Measure, and then add 120 milliliters of acid, for every ounce, or 30 grams, of metal that you are refining. The acid level in the container should be at least half full. No worries, if you are refining only small quantities of metal, and the acid level is not high enough, you can add extra acid to reach this level. However, please note that adding extra acid may require the addition of some extra urea prior to precipitation of your gold. On average, it takes about 1 to 2 hours for the metal to dissolve. However, this can vary considerably because of several factors. High silver content. Silver does not dissolve in Aqua Regia. It forms an insoluble salt called silver chloride, which can coat your gold, making it difficult for the solution to come in contact and dissolve the gold. Normal silver content in 14-karat gold is 6%. 10-karat and 18-karat have higher silver content. Green gold is also very high in silver. Surface area. The greater the surface area, the faster the metal will dissolve. Filigree and ladies' rings have very high surface area. Gents' rings have low surface area. Shot, especially small or flat shot, has very high surface area. Temperature. This system is designed to run at normal room temperature. You can run it in a cold environment, but this may significantly slow the process. For every decrease of 20 degrees Fahrenheit, the dissolving speed will be cut in half. When the metal has all dissolved, it's time to filter out any undissolved solids from the solution, and then add quadratic to precipitate particles of gold that should have a purity of at least 99.95%. Since we will be bringing the reaction chamber outside, let's first disconnect the quick connect from the chamber. Filtration is generally done out of doors or in very good ventilation. You will need your reaction chamber, quadratic precipitant, urea, drip ring, rubber gloves, and precipitation cap. Remove the dissolution cap, and lift out the basket. Placing the drip wheel between the basket and the chamber will support the basket as the solution drains into the chamber, leaving all undissolved solids behind in the pouch. When it finishes dripping, you can store the basket and drip wheel in a plastic bucket, or any similar container. Add just a pinch of urea. In most solutions, this is all that is needed to remove any free nitrogen ions from the solution. In the rare instance where you might have added more acid than was required to dissolve your metal, you may have to add more urea. You will know this by checking whether the urea fizzes when you add it. If there is no fizz, then no more urea is required. If it fizzes, just add more urea till it doesn't fizz anymore. Now, add 1 ounce, or 2 level tablespoons, of quadratic precipitant for every ounce of dissolved metal. Quadratic precipitant is what is called a selective precipitant. It converts just the gold back into particle form. All other metals will remain dissolved. Put your precipitation cap in place, and bring the reaction chamber back inside. Connect the scrubber's hose, and then plug the immersion heater into your timer. Press the timer setting button to set the time to 1 hour. The immersion heater will significantly raise the temperature of the solution, activating the quadratic precipitant. Typical precipitation time is between 30 to 60 minutes. Please note that the solution level should be at least half full. Low fluid level will damage the heater and cause it to burn out in a very short period of time. In the unlikely circumstance where you discover that you didn't add enough acid before starting the dissolving process, and you now see that the solution level is too low, no worries. You can easily fix that mistake. Just add some more hydrochloric to raise the level. Then add additional urea to ensure that no gold redissolves. Testing to ensure that no gold remains dissolved. When precipitation has concluded, no gold remains dissolved in solution. We will now test the solution to ensure that precipitation has finished. Remove the thermometer. Then take a small sample of the solution using the pipette. Place a couple of drops of the solution on the spot plate. Now, add a few drops of precious metal test solution to the sample. If any gold remains dissolved in solution, the sample would immediately turn purple or black. This test is exceptionally effective. Even 4 parts of gold per million parts of solution will cause the sample to change color. If you see a color change to purple or black, give the solution more time to complete precipitation, and then test again. You can test as often as you like. However, be sure to rinse the pipette thoroughly, inside and out, after each test, to ensure that you obtain a clean and accurate result. Squeezing the pipette's bulb repeatedly, while its tip is immersed in water, will force water, in, and out, of the pipette, cleaning its inner surface. When the test yields no color change to purple or black, then no gold remains dissolved in solution. And it's time to decant the solution, and rinse the precipitated gold mud. Rinsing. Having confirmed that no gold remains dissolved in solution, it's time to recover your precipitated gold. Bring outside your reaction chamber, a plastic bucket, and a gallon of water. Remove the cap from the reaction chamber. Decant, that is, pour off slowly, the solution. Because quadratic precipitates large heavy particles of gold, these particles should remain in the bottom of your reaction chamber when you decant the acid. However, you should save this solution for a while. If for any reason, you feel that you have inadvertently poured off some particles of gold with the solution, they will be at the bottom of your bucket, awaiting retrieval. Once all the acid has been decanted, you will see brown-colored gold particles in the bottom of the reaction chamber. The color of the particles can be anything from a very dark brown to a light pale brown. Often it is a combination of browns, commonly with yellow or goldish-colored particles mixed in. The color will vary depending upon the shape and size of the particles, but will have no bearing upon the purity of your gold. Add a small amount of ammonia. Just enough to cover the gold mud. The ammonia will quickly change from clear to blue, as it reacts with the dissolved copper that is clinging to your gold particles. Decant the ammonia. You can pour the ammonia into the bucket. However, if you do that, please be careful. The ammonia will react with the acid, and it may spit. Add water. You can use either tap water or bottled water. Fill the chamber within about 2 to 3 inches from the top. That's about 2 liters of water. Then give the particles a few minutes to settle to the bottom of the chamber. When the particles have settled, decant the solution, taking care that all the particles remain in the chamber, and are not inadvertently poured off with the water. Bring your chamber back indoors. We are going to test, to ensure that no dissolved impurities are clinging to the gold mud. Tilt your chamber. The small amount of water in your gold mud will drip down, puddling in the bottom corner of your chamber. Using your pipette, take a sample of the water. Place a drop or 2 on the spot plate. Add a drop of ammonia test liquid. This test will ensure that no dissolved impurities will remain clinging to your gold mud. If you see any change in color, even the palest shade of blue, then rinse again with water, and repeat the ammonia test. When the test results are negative, that is, when no color change occurs, Your gold will be at least 99.95% pure. Give the gold mud a final rinse with about a cup of distilled water. This rinse will wash away any minerals or other impurities that might be in your tap water. Before removing the gold from the chamber, give it a chance to dry thoroughly. When wet, the gold will stick to the sides of the container, making it difficult to remove. However, when dry as the Sahara, the gold will pour out like sand. If you don't want to wait for your gold mud to air dry, you can quickly dry it with a hot plate. To do this, first rinse the gold into a beaker or any glass container that is made for heating. Be sure to rinse with distilled water, not tap water. Turn on the hot plate. Heat until the water has thoroughly evaporated, and the gold is as dry as the desert. Melting. So now you have highly refined gold powder, and it looks like, well, it looks like dirt. To restore the beautiful, anisotropic gold color, you will need to melt the powder. Typically, melting is done by torch, so that is the method we will illustrate. Here is what you will need. Melting torch. Use a torch made for this purpose. The common propane torch simply will not provide enough BTUs to do the job. Crucible. You can use a standard clay graphite crucible, a ceramic cup-shaped crucible, or you can use a burner ceramic crucible. Crucible rest. Any refractory material, like a brick or a cinder block for example, will do the job. Flux. Common fluxes that are typically used include borax, boric acid, or a combination of the two. Alcohol. Preparing your crucible. Select either an unused crucible, or one that has only been used to melt refined gold. When using a fresh crucible, you must first flux it, sealing its pores, thus preventing it from absorbing gold. Heat your crucible to red hot. Sprinkle flux on the inside of the crucible. A mixture of 50% borax and 50% boric acid is the most commonly used flux. The flux will melt rapidly, forming a thin glaze and sealing the crucible's pores. Wrap your gold powder in jeweler's tissue paper. If that is not available, you can use a small section of a paper towel. Soak the wrapped gold powder in alcohol, and place it in your crucible. The paper and alcohol will help secure the powder, so that the air currents produced by the torch flame don't blow it away. Both paper and alcohol will burn away, leaving no trace. Melt your metal. When it flows like water, pour it into an ingot mold to make a bar of gold, or pour it into ice water to make shot. If you have any questions regarding melting or any other part of the refining process, please feel free to contact Shor. We will be happy to help you. Remember, the only stupid question is the one you don't ask.